So the purpose of this video is to be able to check your work on our sources of carbon dioxide experimental work. And really the key question is, where's this carbon dioxide, this heat trapping gas in our atmosphere coming from? So the first thing I wanted you to do was some start thinking questions and just listing what you already know about carbon dioxide. And some of this might be from our unit, some of it just might be from previous knowledge and experience, but you don't have to have this full list, but here are some things that came to my mind. That carbon dioxide traps heat, which makes it a greenhouse gas. Now, from the global warming game that you watch Mrs. Shields and I play, that means when we say it traps heat, it can absorb infrared photons, but remember, it does not absorb the wavelength of light called visible light. This, you probably could have told me before our unit, that its chemical formula is CO2, which means that the molecule is made of one carbon and two oxygen atoms. And then this, you might remember from 7th grade, that plants take in carbon dioxide and produce glucose, sugar, and oxygen. And then we actually breathe out the carbon dioxide because we take in oxygen. So that there's this connection between carbon dioxide and the carbon cycle and energy cycles in life science. Okay, so then you watched me as a younger woman detecting carbon dioxide. And so let's go through those questions. How did I even get pure carbon dioxide? I mixed baking soda and vinegar. And then remember, you saw me pour that gas over the candle. And so how do we know it wasn't oxygen? It's really this: the candle went out. Oxygen would have increased the flame size, and we did not see that happening. Okay, so then you made a hypothesis. Eventually you made a hypothesis. Let's get to that point. So you knew that we were testing 4 different sources of air to see their carbon dioxide, and you ranked them. And so then you can reflect on how did you do in your rankings. So our data was actually collected in this data sheet with the balloons. And at the end of watching all the testing, here's what we have. Whoops, not quite. Try that. There we go. Let me move me a minute. If I'll move, maybe I won't. Okay, so we have, of course, brown methyl blue is blue. The reaction gas was yellow, and that tells us that it is almost pure carbon dioxide, but the car exhaust was right there. Human breath, we sometimes get into this whole thing. Was it bluish green or greenish blue or just plain green? I think it's pretty green, so somewhere in the middle. And then air from the pump stayed blue, showing very, very little to no carbon dioxide in the air around us. So now check your work on this. There's no other way to be right. For the results, we have the least from air from the pump, middle human breath, and car exhaust is very close to pure carbon dioxide. And we're going to be learning next about fossil fuels, but here's the basics. Fossil fuels like gasoline are made of carbon, so when you burn them, they make carbon dioxide. Now, thinking about controlling the amount of carbon dioxide in the atmosphere got us into these drawing conclusions. But first, what might have been surprising? Here are some things that I've heard students in the past say. We hear as little kids, we breathe in oxygen, we breathe out carbon dioxide, but it must not be pure carbon dioxide or that would have turned yellow. So sometimes students are surprised that it was only green. And then through this whole unit, we've been like, ooh, we're worried about carbon dioxide. We see its ability to trap heat, that one carbon dioxide molecule can actually create way more than one infrared photon in the beam game. And so why then did it stay blue if we're so worried about carbon dioxide? So that might have been surprising. Now, I think the source we tested that could be reduced is car exhaust. Now, human breath, I understand you might be thinking about population control, but the one that can ethically, morally be reduced is car exhaust, I would say. So how could we do that? Well, it's already starting to happen in some places to have more fuel efficient cars, to use other energy sources to power cars. I didn't type this, but public transportation in big cities is a big thing because you are, able to transport more people at once. So all those things are good answers. Now, something that I wanted to show you so that you could really understand these results better is this chart. Okay, and then there's a lot going on here, but this chart is showing you the composition of our atmosphere, which means what it's made of, and it's specific to the lower atmosphere. So look at this. A little over 78% of our air is nitrogen in the form of 2 nitrogen atoms bonded together, N2. We breathe that in. Our body doesn't need it, use it, change it. We breathe it out in the same form. Now, check this out. Oxygen in our atmosphere is 20.9%, almost 21%. We breathe that in during cellular respiration in our mighty mitochondria. That is changed to carbon dioxide. So that's why it turned green and not, with our breath, and not all the way to yellow, because we're converting only the oxygen, not the nitrogen. Now, this argon here in small amounts is also part of our atmosphere. But then look at this. Highlighted in green are the greenhouse gases, and there's our primary heat trapping gas, carbon dioxide. But you've probably heard of methane, potentially ozone, even water vapor. Those also have the ability to absorb infrared photons and trap heat. But if you check out the percentages of all of them, they're very, very low, especially when you get beyond carbon dioxide. Well, that stands to reason. Here's why. Think about this. 78% plus 21%, that's 99%. So 99% of our atmosphere is nitrogen and oxygen. That only leaves 1% left for everything else, and argon is taking up a big chunk of that. So does that mean that we shouldn't be concerned about carbon dioxide levels? And the answer to that is no, because like I keep saying, a little goes a long way because of carbon dioxide's ability to do double or triple or quadruple duty even, that one carbon dioxide can absorb and create way more than one infrared photon. And if you look at this level, it says that carbon dioxide is 397 parts per million. This data is just a little old. In recent times, we've passed 400 parts per million. Believe it's to 415. And so that is a significant increase in the last 50 to 60 years. So hopefully that helps you to understand our results. Our next step in this unit is to really look at who, in terms of countries, are mostly to blame for this carbon dioxide issue in our atmosphere.